Welcome to Unit 2 of Engineering Science, Linear Motion. Today, we're going to look at how things move in a straight line, like pistons in engines or trains on tracks. This basic motion is the foundation of so many systems in engineering. By the end of this unit, you'll be able to define different types of motion, describe key terms like speed and acceleration, solve problems using motion equations, and even read and analyze motion graphs. This knowledge is essential for understanding how machines behave and respond in real-life applications. Here's what we'll cover. First, the concept of linear motion, with terms like distance, velocity, and acceleration. Then, we'll look at how to represent motion with graphs. Next, we'll cover linear and relative velocity, when objects move in relation to one another. Linear motion simply means moving in a straight line. Whether it's a lift moving up a building or a robotic arm shifting parts on an assembly line, linear motion helps us understand and control how machines function. It's one of the most basic but essential forms of motion in engineering. Let's talk about uniform velocity. If an object covers equal distance in equal time, say, a car moving at 60 km per hour, it has uniform velocity. But if the object changes speed or direction, like slowing down for a traffic light, that's non-uniform velocity. This difference matters when designing or troubleshooting machines. Imagine walking around a football field, that's your distance. But if you walk from one goalpost straight to the other, that's your displacement, the straight line change in position. Displacement tells us how far out of place an object is, while distance tells us how much ground was covered. Speed is simply how fast something moves. But velocity tells us the speed and the direction, for example, 30 meters per second north. Both use the same unit, meters per second, but velocity gives a more complete picture of motion. Here's an example. A car accelerates from 30 km per hour to 80 km per hour. That's increasing velocity. If it slows down back to 30 km per hour, that's decreasing velocity. In engineering, this helps us design systems that handle speed changes safely.